Now that we have a good idea of what recommendation systems are and where they are used, let us look a little closer at the data science questions behind them. Specifically, what does the data look like and what do we want to do with it? It seems that a simple approach would be to consider this problem as a binary question. Given a pair, a user and a product, should I recommend this product to this user, yes or no? Classification is perhaps the best known machine learning problem and specifically answers yes/no questions. So we could just use our favorite classification method, such as support vector machines or boosting, for example, in the context of recommendations. Actually, we're going to be able to do much more than just giving a yes/no answer. We're going to be able to rank products and even guess how the user would rate them. Let us do the first thing that we should always do in data science. Take a closer look at our data. Netflix, the video streaming service, is a name that is strongly associated to recommendation systems. Clearly, their goal is to recommend movies to their users, but the main reason for this is that in 2006, Netflix did a superb PR coup. They organized a competition with a grand prize of $1 million to the first person who would improve the performance of their current system by at least 10%. While this may seem like a lot of money, it was actually a rather economical way of getting some of the sharpest minds on the planet to work hard on their problems. Academics, researchers, engineers, students, or even hobbyists. Thousands of teams enrolled. It was a huge success and it started the whole data science competition business. The problem was simple. Netflix released a data set of how users had rated movies on a scale from 1 to 5. About 100 million triplets of the form user movie rating were released to the competitors. It was effectively a giant list of the form Bob rated Goodfellas 4, Emily rated Titanic 3, Frank rated Dirty Dancing 5. This is Frank. He really likes Dirty Dancing. This is called the training set, and competitors used it to calibrate or train their algorithm. Along with this set, Netflix also released another million incomplete triplets of the form. Ted rated Rio Grande, Soledad rated Deliverance. The goal is to predict hidden scores. These were real number scores. Integer numbers, 1, 2, 3, 4, or 5, but the predictions could be any number, like 4.52. This was useful if your algorithm couldn't decide between a 4 or a 5. It could mitigate the losses. The performance was measured in terms of what is called root mean squared error. Let's parse this term to define it. Let's say that a competitor predicts 3.4, 4.1, and 2.0, but the true scores are respectively 4, 2, and 3. The errors are 3.4 minus 4, which is negative 0.6, 4.1 minus 2, which is 2.1, and 2.0 minus 3, which is negative 1.0. These can be negative and cancel each other, so we square them to get the squared errors. 0.6 squared is 0.36, 2.1 squared is 4.41, and 1.0 squared is 1.0. Then we average them to get the mean squared error. 0.36 plus 4.41 plus 1 divided by 3 equals approximately 1.9. Finally, the root mean squared error is just the square root of the mean squared error. Square root of 1.9 is approximately 1.38. The last square root operation is not very important, but it allows for the following interpretation. In average, the algorithm made an error of about 1.4 per user movie pair, which is not very good in this case actually. In 2006, the state-of-the-art Netflix system had a score of 0.95, and the winning team dropped this number down to 0.85 after 3 years of hard work. Once the missing numbers are predicted, we can recommend movies using simple rules. For example, we could recommend a movie to a user if the predicted score is at least 4.2. Towards the end of this video, we'll see what else can be done with these predicting numbers, and if there's something else we should be trying to predict.